Hi, hello, and welcome back. Now, I'm going to discuss about the carbon footprint for an application. Here I have taken the application as Campus Result Portal. So, I have taken SRM Campus Result Portal where students can able to view their result and they can also able to download their result as a PDF. This is the scenario. It is a portal where student can able to view and download their result as a PDF. SRM has total of 50,000 students. It is a given data. On an average, they downloads 4 times during the result week. The week where the result get published. And generation of those each PDF takes 5 seconds by the system. And server consumes 400 watts, that is 0.4 kilowatt, and data center PUE, power usage effectiveness, is 1.5, and the carbon intensity, it is 80 gram CO2, that is 0.82 kilogram CO2 kilowatt per hour. It is carbon intensity, and semester results were published 4 times per year. This is the given scenario. And now we'll see the questions one by one. The first question, to calculate the energy consumed in kilowatt per hour to generate one result PDF. So we should calculate the energy consumed to generate a PDF. That is the first question. We'll see. Here, the processing time given in seconds. So first we'll convert the given processing time into hour. How to convert? Convert the processing time into hour. This will be the first step. How will convert? Time is equal to, the seconds given is 5 seconds by 3600. So to convert into hour, this is the formula. Is equal to, the value is 0.001389 hours. After converting the given seconds into hour, we should calculate the server energy. Calculation of server energy. How will we calculate the server energy? And the formula to calculate the server energy is E is equal to P into T. What is E? Energy is equal to, what is P? Power into T, that is time. This is the formula. So we'll apply the values. What is P and what is T? It is given that the server consumes 400 watts. So 0.4 kilowatt into the time. Time taken was already calculated in the previous step. 0.001389 hours. So the value will be 0.000556 kilowatt per hour. The next step, step 3. So first we calculated the time into hours and then we have calculated the server energy. Now what we should calculate is, we should include the data center power usage effectiveness. So applying data center power usage effectiveness given 1.5 into this. So actual energy we are going to calculate using the formula. Actual energy equal to server energy into, what is given, the PUE 1.5. So what is server energy? We have calculated here 0.000556 into the PUE given is 1.5. So what is the value? 0.00556 into 1.5. So This is how we calculated for the first question. Calculating the energy consumed in kilowatt to generate a result PDF. We'll see the next question. The second question. Calculate the total number of PDF generated during the result week and the total energy consumed. We have to calculate this. We'll see how to calculate this. So step 1, first we should calculate the total PDF generations. So total PDF generations. Total PDF is equal to number of students into download per student. So here we have said the number of students in SRM is 50,000. So is equal to 50,000 into download per student. Per student downloads 4 times. So 50,000 into 4. 2 lakhs PDFs. Step 2. What is step 2? Here we are going to calculate the total energy. How will calculate the total energy? So total energy is equal to total PDFs into energy per PDF. So total PDFs is nothing but your 2 lakhs into energy per PDF, which is nothing but 0.00833. We have calculated in the previous question, is equal to, the value is 166.67 kilowatt hour. That is nothing but the total energy. This is what the second question. Now we'll move on to the third question. What is third question? The third question is to calculate the total carbon footprint generated in that week, that is the result week. This is what we are going to calculate. So we'll see the formula. Carbon footprint is equal to energy into CI. What is CI here? Carbon intensity. Okay. So the energy we have calculated is 166.67 into carbon intensity is given in the scenario that 0.82. Since we are calculating in kilowatt per hour, so we have taken the kilogram measurement is given in the question. So the answer is 136.67 kilogram CO2 measured. So this is the answer of total carbon footprint generated during the result week. We'll move on to the next question. The next question is calculating the annual carbon footprint. How will you calculate the annual carbon footprint? It is given in the scenario that the results were published 4 times per year. So, annual carbon is equal to, we have to calculate by using the weekly carbon, that is the carbon emitted during the result week into 4 times the results were published. So it's equal to, what is weekly carbon we have calculated? 136.67 into 4. So the value is 546.68 kilogram CO2 per year. Right? We'll move on to the next question. The next question is green interventions. In this fifth question, there are green interventions that were proposed by the head of the department. We'll see what is that. See, the HOD proposes 2 options. Option 1 is catch generated PDFs. So while using the catch, the PDF will be downloaded only once, and whenever required it will be given to the user instead of downloading all the times whenever the user click the download. So on an average we have seen that the user is downloading 4 times. To avoid that, we are using here catch. So with the help of catch, we download only once. And option 2, what is option 2? We can move the application to the renewable powered data center. Moving application to renewable energy powered data center. So what will happen? The 50,000 students, every 4 times they are downloading the result PDF in a week. Each student downloads at an average of 4 times, and 4 times during the year they will repeat the process by all the students. So it produces more carbon emissions. Now moving this application, what we have, the Resam Research Portal, to the renewable powered data center. Moving to the renewable power data center will save the energy. Since it is using renewable energies like solar, wind, okay, we can save the energy and also will reduce the electricity bill too. And finally, our intention is to reducing the carbon emission, which will also get reduced with this strategy. So we can go with any one of the strategy and choose the efficient one and move on to the any of the option proposed. Now we will see, for each option we have to calculate the annual carbon footprint and we should compare the result. Okay. So option 1, option 2 will calculate the annual carbon footprint. We'll see for option 1 the catch generated PDFs. Here using catch generated PDF, as we said, a student can download only once. So 50,000 student into 1 is 50,000. Previously we have seen it was 2 lakhs and it is reduced to 1 quarter. And the next one, weekly carbon footprint. Weekly carbon footprint will be 41.67 into 0.82 is equal to 34.17 kilogram CO2, which will be weekly carbon footprint. And annual carbon footprint will be, how will calculate the annual carbon footprint? Weekly carbon footprint into 4 times. That is 4 times they are publishing the result. So it's equal to 34.17 into 4 is equal to 136.68 kilogram CO2 per year. And goes into option 2. Moving to the renewable power data center, and here the new carbon intensity will be 50 gram. It is given, so it is 0.5 kilogram, right? Weekly carbon footprint will be 166.67 into the new carbon intensity, which is 0.05. Sorry, it is 0.05. 50 gram is equal to 0.05. So 166.67 into 0.05, which is nothing but 8.33 kilogram CO2 for week. And annual carbon footprint will be 8.33 into 4 times. So the value will be 33.33 kilogram CO2 per year. So comparing the two options, the weekly footprint here from the option 1 is 34.17 kilogram CO2, and here 8.33 kilogram CO2. It is reduced to 4 times than option 1. And annual carbon footprint will be in option 1 as 136.68 kilogram CO2 per year, and here 33.33, also reduced much. So comparing to option 1 and option 2, the option 2 will be better and more efficient compared to option 1. So we'll opt for option 2. So what we will do is, conclusion, that we'll move the result portal application to the renewable powered data center, and we can reduce the carbon emission by this level. Thanks for watching.